All right, well, hello, fifth grade. Today we're getting into chapter 11, and today we're going to be focusing on this idea of um, the metric system. Kind of went blank there. We're going to be combining lessons 11.1 and 11.2 in today's video. That's going to be one assignment. Teachers that may be viewing this video, basically the idea of the metric system, since it's all the same base 10, it doesn't matter whether we're converting mass, capacity, or length. The math behind it is the same. That's why I choose to just combine these into one lesson and one video. But fifth graders, you've heard me talk about base 10 before, and the metric system is all about base 10, where we have several different types of measurements. You see we have milli, centi, deci, deca, hecto, kilo. And it always takes 10 of the next smallest to make the next larger one. So it takes like 10 of these to make one of these, 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 and so forth. And it's also an idea of base 10 in the fact that it takes, like if we were to think about millimeters, it would take 10 millimeters to make 1 centimeter. It would take 100 millimeters to make a decimeter. It would take 1,000 millimeters to make 1 meter, 10,000 millimeters to make a decameter, and it just keeps going by adding a zero. It's another multiplication by 10, which simply just adds a zero. And when we work with decimals, we'll talk about, review how back earlier in the year we talked about how multiplying by base 10 numbers, 10, 100, and 1,000, all you're doing is moving the decimal to the right, how many ever zeros there are in the number. And sometimes we'll also divide, which means we're moving the decimal to the left and making the number smaller. You're going to want to have this chart in front of you, so you need to take a screenshot or write it down or something, but you're going to want to have this chart in front of you because I will be referring to it throughout the examples on this video. All right, well, let's get started. Now, first of all, we have two different types of problems that we could have. And let me go back to the chart to talk about these. We can have it where we're converting a larger unit to a smaller unit, so like deciliters becoming millimeters or hectograms becoming grams or whatever the case may be. The measurement gets smaller, and since it's a smaller measurement, it will take more of them to be the same length, okay? Like 1,000 millimeters is the same as 1 meter, okay? It takes more of them because they're a smaller unit, okay? So it takes more of these to get, one of these. And so when the measurement is getting smaller, we're going from meters to millimeters, the number's actually going to get bigger because it takes 1,000 of these. This is 1,000th of a meter, okay? It takes 1,000 of them. Kind of got a little fuzzy there. Sorry about that. And so the measurement is getting smaller. The number is getting bigger, so you're going to multiply. Now, when we're moving up this way, like going, say, from deciliters to kiloliters, or the idea that 1,000 meters is the same as 1 kilometer, it's 1,000. When the measurement gets bigger, the number gets smaller, because if I have 1,000 meters, I only have 1 kilometer, because kilometers takes 1,000 of the base unit, which is 1 meter, 1 gram, or 1 liter. And we'll talk about this more when we're converting. So when the measurement is getting bigger, the number is getting smaller, so we're going to divide. Now in this first set here, this goes with the measurement is getting bigger, so the number is getting smaller, so we are dividing. So, for example, it says 30 decimeters is equal to how many meters? Well, so I'm going to come up here. I want to find the decimeters, and here's the meters. So the measurement is getting bigger. The number is getting smaller, which means I'm dividing. Well, what am I dividing by? Well, I'm only going up one place. And so since I'm moving to the next bigger place, I'm going to divide by 10. If I was going up 2 places, I would divide by 100. If I was going up 1, 2, 3 places, I'd be dividing by 1,000. But I'm only going up one place, so I'm going to be dividing by 10. So it's 30 divided by 10, which tells me that 30 decimeters is equivalent to 3 meters. All right, 460 centigrams is equal to how many grams? Well, let's come over here. Here's our centigrams. We're going from centigrams to grams. So we're going up, we're going bigger up the chart. Remember, these are the bigger measurements. These are the smaller measurements in relation to a meter. So I have centigrams, and I have 460 of them, and I want to figure out how many grams there are. So the measurement is getting bigger, which means the number is getting smaller, which means I'm dividing, but what am I dividing by? Well, I'm going up 1, 2 spots. So that's times 10 is 10, times 10 more is 100. So I'm doing 460 divided by 100. Now remember what that rule is. When I'm dividing by a base 10 number, I'm just moving the decimal to the left. Well, you say there's no decimal in 460. Well, that decimal goes right there, as we've talked about before. There are 2 zeros, so I'm moving that decimal once, twice to the left, once for each 0. I end up with 4.6 or 4.60. 4 6/10 grams for 460 centigrams. 4,335 milligrams equals how many grams? Well, we're going to go from milligrams to grams. So we're going from milligrams here to grams here. So once again, the measurement is getting bigger. So the number is getting smaller. So we're going to divide. Well, what are we going to divide by? Well, 1 place is 10. 2 places times 10 is 100. 3 places times 10 is 1,000. So I'm taking 4,335 and dividing that by 1,000, which means I'm going to move the decimal 1, 2, 3 places to the left. No decimal, not a problem. We know it goes right there. Moving it 3 places to the left, once, twice, 3 times, 4 and 335 thousandths. 4 and 335 thousandths grams for 4 and 335 thousandths grams for 4,335 milligrams. Last one for this set, 45 centimeters equals blank millimeters. Now, not all the time will it refer back to the base unit of meters, grams, and liters, because this is where everything is in the middle, gets smaller with deci, centi, and milli, gets bigger, deca, hecto, kilo. 45 centimeters equals blank millimeters, okay? Well, actually, I'm going to change that. I flip those around. We're going to make 45 millimeters equal blank centimeters, because I want to make sure that we're going from a smaller unit to a bigger unit. That was my mistake initially. So if we have 45 millimeters equals blank centimeters, we're going from milli to centa. Well, once again, the measurement is getting bigger, which means the number is going to get smaller, which means we're going to divide. Well, what are we going to divide by? Well, we're only going one place. We're going from milli to centa, millimeters to centimeters. So I'm just going to divide by 10. So this is going to be 45 divided by 10. Well, 45 divided by 10, there's no decimal in 45. I take the decimal, I'm going to move it 1 place to the left, right there, 4 and 5/10. 45 millimeters equals 4 and 5/10 centimeters. All right, well, let's go to the next slate. And it's only one set of directions, and they're all mixed together, 5th graders. So, but here in this case, okay, And let me get my chart back here. Here in this case, we're going to be going from bigger to smaller measurement. So 3 7/10 kilometers equals blank meters. So I come over to my chart. Here's kilometers, here's meters. So I'm going to the right, which means my measurement is getting smaller, which means my number is going to get bigger because it's going to take more of them to have the same amount. So I'm actually, in this situation, going to be multiplying. When the measurement gets smaller, the number gets bigger, so we're going to multiply. Well, what am I multiplying by? Well, it's 3.7 kilometers equals blank meters. So I'm going from kilometers to meters. Well, one place is times 10, two places is times 100, three places is times 1,000. So I'm taking 3.7 and I'm multiplying that by 1,000. So if I get out here, 3.7 times 1,000. Now remember what that means. It means I'm just moving the decimal 3 places to the right. I'm multiplying. So now the decimal is moving to the right. Once, twice, 3 times. The decimal is there. I fill the empty spots with zeros. I find that 3 7/10 kilometers equals 3,700 meters. 270 hectoliters equals blank liters. Well, we come over here, we have hectoliters here, we have liters here. And so, once again, the measurement is getting smaller because I'm moving to the right. I'm going from here to here, which means the number is getting bigger, which means I'm going to multiply. Well, what am I multiplying by? Well, I'm going from hectoliters to liters. One place is 10. The other place times 10 more is 100. So I'm taking 270, and I am multiplying that by 100. Well, that means I'm moving the decimal 2 places to the right because there's 2 zeros in 100. No decimal in 270, it goes right there. Once again, 5th graders, you can't be confused when the number doesn't have a decimal. You have to understand that it just goes right there to the right. Times 100, move it 2 places. I'm going to fill those spots in with zeros. I get 27,000. 270 hectoliters equals 27,000 liters. 47 decaliters equals blank deciliters. 47 decaliters equals blank deciliters. Well, here we go. So here's decaliters, here's deciliters. So once again, we're going from here to here. So the measurement is getting smaller, which means the number is getting bigger, which means I'm going to need to multiply. Well, multiply by what? Well, one place times 10 times 10 more is 100. So I'm going to be multiplying the number of decaliters by 100 to see how many deciliters there are. Well, I have 47 decaliters, so I'm going to take 47. I'm going to multiply that by 100. All right, now here, once again, I can also use the zeros trick. In the previous example, we talked about moving the decimal, but I can also use the zeros trick, okay, which I'll remind you of here. 47 times 1 is 47, so we put that down. And then I just add the 2 zeros on, and I get 4,700. Moving the decimal, if I put the decimal right there, moving the decimal 2 places to the right, would have got me the same exact answer, 4,700. All right, last one. 3 7/8 hectoliters equals blank centiliters. 3 7/8 hectoliters equals blank centiliters. Well, here we have the hectoliters. Here we have the centiliters. So once again, I know I'm going from here to here. So the measurement is getting smaller, which means the number is getting bigger, which means I'm multiplying. Well, multiplying by what? Well, from here to here would be times 10, times another group, times 10 is 100, times 10 is 1,000, times 10 more is 10,000. So I have to multiply the number of hectoliters by 10,000 to find the number of centiliters. Well, the number of hectoliters is 3.78, and I'm multiplying that by 10,000. Well, there are 4 zeros here, so I need to move my decimal 4 places to the right. Once, twice, 3 times, 4 times. fill in these empty spots with zeros. Looks like I get 37,800. 37,800. Fifth grade, that's converting units in the metric system, mass, capacity, length. All right, we'll talk to you later.